In this video, we will solve problem 5.20. So in this problem, we have to see consistency of the Ampere law, whether it is consistent with the general rule, that is equation 1.46. The equation 1.46 is the divergence of curl is always 0, and we have to show that the Ampere's law cannot be valid in general outside magnetostatics, and we have to find out if there is any such defect in the other three Maxwell equations. So let's get started. We will solve this problem with the all basic that is required to solve this problem. So let's get started again. So this is the, first of all, this is the Maxwell. These are all the four Maxwell equations with the Maxwell's correction. First of all, let us assume that we do not know this correction. So let's hide it. So we just know that del cross V is equal to mu naught J. So let's check it whether it is consistent with the divergence of curl or not. So we have given that del cross B, del vector cross B vector is equal to mu naught J. So when we take divergence of it, so divergence of curl of V is equal to mu naught del vector dot J vector. So actually it is a vector dot J vector. So from the continuity equation, we know that del rho over del T plus del vector dot J vector is equal to G. So from here, this is what? Minus mu naught del rho over del T. So this is not 0. To make it 0, rho should be constant. To make it 0, rho should be constant. That is what is magnetostatics. That is what is magnetostatics. So this is not 0. So Ampere's law cannot be valid. This much is true. Now we have to find out is there any defect in other Maxwell equation or not. We will see in the coming slide. So first of all, that we have to check this equation, so whether it is correct or not. So let's see third equation, that is Faraday's law. So let's take divergence of it. Del vector dot del vector cross E vector is equal to minus of del vector dot del B vector over del T. And we can say, we can take this partial differentiation out and we can write it as minus del over del T del vector dot B vector. So using second that has no name, that is del vector dot B vector, that is divergence of magnetic field is 0. So it is 0. So we can say this equation is also correct. And we are using this equation, we are using second equation, so this is also correct. To prove third equation, we are using second equation, so this is also correct. Now I have one question for you. What is this question? Let me say. So this is the divergence of curl. This is the divergence of curl. So can I say curl of divergence curl of divergence, can it exist? Can it exist? Please let me know in the comment section. We have checked this equation, this equation. However, without Maxwell's correction, we check Ampere's law, which was not consistent, which was not valid. Now let's say we know Maxwell correction. Let's say we know Maxwell correction. Now we have to check whether this fourth equation is correct or not. So let's again take, let me write it. These are Maxwell equations. Let's take divergence, that curl of V. Now I am taking divergence is equal to mu naught del vector dot j vector plus mu naught epsilon naught, and this del by del t, I can take it outside, so I can write it as del by del t rho vector dot e vector. In the last slide, we know that what is this? This is mu naught del rho by del t plus mu naught epsilon naught. Now this is divergence of E, that is Gauss law. Here first equation, that is Gauss law. So we can write it as, that is del by del t rho over epsilon naught. Now this epsilon naught cancel out this epsilon naught, so minus k mu naught minus mu naught del rho over del t plus mu naught del rho over del t, and this is 0, this will cancel out. So with the Maxwell's correction, we are getting the divergence of curl is 0. So we are getting del vector dot del vector cross V vector is equal to 0. So with the Maxwell correction, this fourth equation is also correct. So this is also correct. However, we used Gauss law to prove this, so this must be correct. So these all four Maxwell's equations are correct. So this is correct, this is correct, this is correct, this is correct. That's how we can approach this problem. Thank you.